In this lecture, we are going to discuss the worst case analysis of insertion sort. For this, I have taken the input 5, 4, 3, 2, 1. It is a reversely sorted input. So, reversely sorted input. And the number of elements in the input list, it is 5. So, now we'll see how to work on this problem. So, the given input is 5, 4, 3, 2, 1. So 0, 1, 2, 3, 4. And what we'll do here, the very first element should be a sorted one and the remaining elements are unsorted. This is how we do an insertion sort. And what is the next step? We have to take the temp value. What is the temp value? The very first element from the unsorted list is temp value. What it is? It is 4. What is the next step? We have to compare the elements from the sorted list with this temp. So we have to start from the last position of the sorted list. So it is check whether 5 greater than 4. It is true. Now increment the position of 5. So it is 5, 3, 2, 1. Now just check, is there any other element left out on the sorted list? If it is there, then we have to make one more comparison with the temp. Here we just have only one element, so we don't have any other elements in the sorted list. Now you can bring your temp value 4 to here. What happens now? So this is my sorted list and this is my unsorted list. What is the next step? You have to take the, now you have to reassign the temp. You have to take the very first value from the unsorted list. It is 3. Okay, it is now it is 3, right? It is 3. Then what happens here? So you have to compare the elements from the sorted list with this temp value. We have to start from the last position of the sorted list. So in the last position of the sorted list we have 5. Just check whether 5 greater than 3. True. If it is true, you have to increment the position of 5 by 1. So what will happen here? So 4, you have a holder here, 5, 2, 1. Yes. What is the next step? What is the element left out on the sorted list? We have one more element. It is 4. Just check whether 4 is greater than 3. True. What we have to do? We have to increment the position of 4. So create a holder here. Move the position of 4. Increment by 1. So it is 4, 5, 2, 1. Are there any other elements left out on the sorted list? No. That time you can bring 3 here. So now the list becomes 3, 4, 5, 2, 1. What is the next thing? So this becomes sorted and this becomes unsorted. So again we have to reassign the temp. How to assign temp? The very first element from the unsorted list is what? Temp. So now the temp is 2. Temp is 2. So what is the next thing we have to do? Just compare the elements from the sorted list. Start from the last position and move up to 0th position in the sorted list. Just make it 5 greater than 2. It is true. If it is true, just move the position of 5. What will happen here? 3, 4. A holder will be created. 5, 1. Is there any other element left out in the sorted list? Yes, it is 4. Is 4 greater than 2? True. If it is true, you have to increment the position, right? So this is 3, 4, 5, 1. Is there any other element left out on the sorted list? Yes, we have 3. Check whether is 3 greater than 2. It is true. You have to increment the position of 3. So this will become 3, 4, 5, 1. What is the next step? Just check whether any other element left out on the sorted list. No. Now you can bring 2 here. So this is my rearranged list. 2, 3, 4, 5, 1. Now what happens here? So this will become sorted and this is unsorted. So what we have to do? You have to take the very first element from the unsorted list and assign it to temp. So now this is my temp 1. Okay. What is the thing we have to do? Take the last element from the sorted list and just make the comparison and keep doing this until you reach the 0th position of your sorted list. Just check whether 5 greater than 1. True. What will happen? Just increment the position of 5. Just what is the element that are left out in the list? It is 4. Just check 4 greater than 1. True. Then increment position of 4. What is the next element? It is 3. 3 greater than 1. True. just increment the position of 3. What is the next element? Is 2 greater than 1? True. Increment the position of 2. Are there any other element that are left out on the sorted list to make the comparison? No. Now you can bring the 1. So this is my sorted list 1, 2, 3, 4, 5. For which kind of input? The input here is what? Input for this is reversely sorted. Now we'll make the analysis. Let us do the analysis. Here, how many comparisons it is making? If you see here, it is making how many comparisons? 1 comparison. Yes. Here it is making how many comparisons? 2. Here it is 3, 4. So on the whole, it is making, remember, total number of comparisons, it is 1 plus 2 plus 3 plus, so here 1 plus 2 plus 3 plus 4, right? Sorry, 4. So this is of the form 1 plus 2 plus 3 plus up to n minus 1. So it is of the form, what is that? N into n minus 1 by 2. Yes or no? So this is of the form n into n minus 1 by 2, which is n square. So at the worst case, how many comparisons it will make? N square, that is the time complexity of insertion sort in the worst case is order of n square. Thank you for watching this. Thank you for watching this.